Hey guys, today we're going to graph secant and cosecant functions. Okay, so far for the past few weeks, we've been working on graphing sine and cosine. You guys have gotten pretty good at graphing those two. And now you'll see that once you know how to graph sine and cosine, you can pretty easily figure out how to graph secant and cosecant. All right, so the first thing, guys, is you need to remember which functions are reciprocals of one another. So sine is the reciprocal of cosecant, and cosine is the reciprocal of secant. All right, that's going to be very important. You need to keep that straight moving forward and not mix those up. All right, so now the key to graphing these is using what we're going to call a guiding graph. Okay, so the guiding graph is literally the same exact function, except if it's a cosecant, I'm going to rewrite it instead as sine. And if it's secant, you change the word SEC to cosine, COS. Okay, so we're going to start basically by graphing this guided graph with a dashed line, and you'll see how that will help us transform it into this secant graph. Okay, so first, we're going to figure out all the critical information for our guided graph here. So you guys should know how to do all of this now. So amplitude here is 1, period is 2 pi over b, b is 2, 2 pi over 2 is pi. Your DCV is the distance between critical values. You take the period divided by 4. Phase shift, C over B. C is pi over 2, B is 2, pi over 2 divided by 2 is like pi over 2 times 1/2, which is pi over 4. But remember to specify which direction is your phase shift. In this case, it's to the left, evil inside. C is positive, plus means to the left. And finally, the last one, the axis of the wave here, or your midline, is at 0. All right, so now here are going to be your key steps to graphing these. Number 1, draw your guiding graph. Okay, so basically, actually graph this sine function here that we've written as our guiding graph. Number 1 is draw that in a different color. And number 2 thing with that is make it a dotted or dashed line. Okay, the guiding graph is just there to help you make the real graph. Okay, so you don't want to graph the guiding graph and then forget the whole purpose of it, which is to transform that into a cosecant or into a secant. Okay, number 2, all right, midline points are going to become vertical asymptotes. You'll see what that means in a sec. Okay, max and min points are shared by both the guiding graph and the actual graph. Okay, and finally, between asymptotes, the guided graph and the actual graph are going to be a reflection of each other. So basically, once you have your sine graph, you're going to reflect it, and that's cosecant. All right, so instead of trying to understand what all of this means, let's do it one step at a time. So your first step is to graph the guiding graph. So I'm actually graphing this here, y equals sine 2x plus pi over 2. So I have all the critical information here in this table, and so I'm going to graph this in blue. Okay, in Cami, it's very easy to change colors. Over here, you click drawing. It should have a palette for you. Make sure you choose a different color to show that that's your guided graph, not your real graph. All right, so my midline is 0. So I'm going to draw a little dashed line here. And I'm making it slightly above that x-axis just so you can see it. Okay, you could also extend it to the side to show that 0 is your midline. All right, now I'm going to call this 1. Okay, and since the amplitude is 1, that's the max. Here's -1, and since amplitude is 1, that's the min. Okay, next things, let's scale by our DCV, which is pi over 4. So I'm going pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4, and then 4 pi over 4 is pi, and the same for in the negative direction. Okay. Now remember, you're graphing your guided graph. So I'm graphing this sine function up here. Remember that sine starts at the midline. So my starting point would be here at the origin 0, 0. But instead, we have a phase shift of pi over 4 to the left. So my starting point moves over here to the left. Okay, so again, normally sine would start here, but I've moved over to pi over 4 to the left because of my phase shift. Now remember, this is positive sine. So positive sine from the starting point, the next point to the right is at a max. Okay, that means I got to go back down to midline, then to min, back to midline, and to max, and keep that pattern going. All right, and then the last thing is when you connect the dots here, you want to try and make this a dotted line for yourself. Remember that this is not the actual graph. This graph is just helping us to create the cosecant graph. All right, so now that is what this picture here is, the guided graph, which is y equals sine of 2x plus pi over 2. So now we've done step 1. Okay, now step 2. Here's the key to transforming a sine graph or a cosine graph into cosecant or secant. Anywhere that you had a midline point on your sine graph, if it's on the midline, that means that those x values, sine of that was 0. Okay, so you could think of it as like 0 over 1. And remember that cosecant is a reciprocal, so we're flipping it. So if I take something like 0 over 1 and flip it, I get 1 over 0. 0 underneath means undefined. Okay, and therefore, what do I have at all those midline points? I have asymptotes. Okay, so everywhere that you see a midline point on your sine graph, and sorry, I should switch now to black because this is my actual graph I'm creating here. Those are vertical asymptotes. Okay, so everywhere that you see a midline on your sine graph, when we turn it into cosecant, that's an asymptote now. Okay, because if we get 0 for sine, that means we get undefined for cosecant. Okay, so now we've created those into asymptotes. Done with step 2. Step 3, max and min points are shared by both. So these max and min points are actually also on your cosecant graph. Okay, so max and min points are shared by both. Okay, finally, last step. Between your asymptotes, the graphs are a reflection of one another because the functions are reciprocals. Okay, so like here to the left, I have basically like an upside down, almost parabola looking shape here. So in my cosecant graph, sorry, that should have been in black, it's going to reflect and look like this. Okay, here, the sine graph, it was facing up. Now it flips. Okay, so basically, every point that was a max for sine is now a minimum for a cosecant because everything goes up from there. Everything that was a min, so here, like this point here was a min for sine, it's a max for cosecant. Everything goes down from there. Okay, or if you look here, the blue dotted line in the middle here, the blue dotted line is facing down, my parabola is facing up. Okay, so now we are done. Okay, we've reflected them. And so this black in black here, including the asymptotes, is my graph of y equals cosecant of 2x plus pi over 2. And again, you use the blue dotted line to guide your graph. All right, guys, your assignment for today is to complete problem number 2 and submit it to me. Okay, you have two choices. Okay, you can either do number 2 on this worksheet, or you could open a blank CamiDoc, open a grid paper, and graph it on a blank piece. Okay, but you have to submit to me today as your assignment just one graph, number 2, and that's your grade for the day. All right, guys, I'm available right now on email, Google Classroom, etc., and I'll be available after school in Zoom for my optional extra help session if you guys have questions on what we learned today.